So in this video we are going to be talking about the 6 trig ratios. To begin with though, we need to talk about angles and what it means to be the opposite and adjacent sides. So here is the symbol theta, and over here we have the symbol beta. So when we're talking about this angle theta right here, the opposite side is if you were standing at this wall, almost like it was a projector, what wall would be projected onto. That is the opposite side. The adjacent side is the one that's touching the angle that is not the hypotenuse. Remember, the hypotenuse is the longest side and also the opposite of your 90 degrees. So over here, beta, this side is considered the adjacent because it's touching beta, and the opposite is the one over here. Because again, if I were standing over here, I would be projecting onto this wall. So we have 6 trig ratios. You are probably all familiar with the first 3 of sine, cosine, and tangent with that lovely SOHCAHTOA. We also have the numerical or the symbols for our sine, cosine, and tangent. So you can see how it's actually spelled. So sine has an E at the end of it. And we also have the 3 what we call the reciprocal trig functions. So cosecant, secant, and cotangent. So the first one is sine, and sine is going to be the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite side over the adjacent side. So these are the 3 that you were used to. This is your SOHCAHTOA. So now we're going to be talking about the reciprocal trig functions, which you may not be familiar with. So the first one is cosecant, and cosecant is the reciprocal of sine. So if you remember reciprocal, it basically just means, hey, flip that fraction. So for cosecant, it's the hypotenuse over the opposite side. So as you can see, if I'm looking at this sine up here, if I were to just flip that, I get out my cosecant. So for secant, it is the reciprocal of cosine. So here it is the hypotenuse over the adjacent side. Again, if you looked here at cosine, you would see that it's just the reciprocal. This fraction is just flipped and it becomes secant. And the last one is cotangent, and by the name alone you should be able to guess what reciprocal function this one is, and it is tangent. So it is the reciprocal of tangent. So this one is the adjacent side over the opposite side. So we are going to be working with all 6 of these this semester. So get used to these ratios, and when you see a right triangle, how these ratios actually are going to be working. So we're going to work on some examples now. All right, so the first example, we are asked to find all 6 trig ratios, and we are given that we have a triangle. It is a right triangle with the angle at B. Side BC is going to be 8 centimeters, side AB is 15 centimeters, and we're asked to find the 6 trig ratios. So the first thing that you should always do when you are working with a math problem is to draw it out. So I'm going to start by drawing a right triangle. So it does not matter what your right triangle looks like. My right triangles, no matter what the side lengths actually are, my drawing always looks like that, where you have an angle at the left side and then you have a vertical line on the right side. That's just how my drawings always go. So here we know that this is going to be angle B, so I'm going to mark it with B. And what I'm going to do now is I'm just going to label the other 2 angles either A or C, because we know that we're working with the triangle ABC, so I know the other 2 must be named A and B. It does not matter which one is which at all. This is a rough sketch. So I'm told that I also have BC. So BC, so that means from angle B to angle C is the length of 8. So I know that this is 8 centimeters. I also know that AB, so from A to B, that is a length of 15 centimeters. And I'm asked to find all of these trig ratios in relationship to A. So what I'm going to do is I'm just going to put a little theta right here at A just to kind of show me, hey, I'm working with that angle right there. So I now know that I have an opposite side and I have an adjacent side. So my opposite side is going to be this 8 centimeters. So this is my opposite side. And my adjacent side is the one that is touching it, that is not the hypotenuse. So the only thing I need to still know is, what is the hypotenuse? So we can do that math. So this is a right triangle, so you can do Pythagorean Theorem, a squared plus b squared equals c squared. And you can figure out what the hypotenuse is. Remember, the c squared is always your hypotenuse. You may also notice that this is an 8, 15, 17 triangle right off the bat. So we actually know what this other side is, and it's just 17 by that Pythagorean triple. So now that I have all that information, I can start doing it. So I know that sine is opposite over hypotenuse. So my opposite is 8, and my hypotenuse is 17. So the ratio for sine is 8 over 17. Then we can go to cosine. Cosine is adjacent over hypotenuse. So my adjacent was 15, and my hypotenuse is 17. And lastly, we have tangent, and tangent is opposite over adjacent. So my opposite is 8, my adjacent was 15, and that's the first 3. So the other ones are just the reciprocals. So cosecant is the reciprocal of sine, so I just need to flip this fraction. Secant is the reciprocal of cosine, so I just have to flip its fraction. And cotangent is the reciprocal of tangent, so I just need to flip its fraction, and we're done. So the first thing you need to do is sketch out the problems, sketch out all the information that it was given to you, and label those sides with opposite, adjacent, and hypotenuse, and it will probably help, or use some kind of color coding. So let's look at another one. So it says, assume that the angle is an acute angle in a right triangle. Evaluate the remaining trig functions given that the cosine of theta equals 4. So again, let's start by sketching out this triangle. So here is my theta. So I'm given cosine. So cosine is adjacent over hypotenuse. So that means that my adjacent side is going to be this ratio of 3, and my hypotenuse is going to be the ratio of 4. So I just need to find whatever this other side is, which would be my opposite side. And to do that, this isn't a 3, 4, 5 triangle. It may look like it to you at the beginning, but that last ratio is always the hypotenuse. So this is not a 3, 4, 5. This is a 3 something 4. So we need to figure out what that something is. So we're going to use the Pythagorean Theorem, which is again a squared plus b squared equals c squared. So we know the hypotenuse is 4. We know one of our angles or sides is 3. So I just need to find the last one. So this is a squared plus 9 equals 16. So this is a squared. So subtract 9 on both sides gives you 7. And then take the square root of both sides. So the last side is just the square root of 7. So we need to find our ratios for all of these. So sine is the opposite over the hypotenuse. So again, we have the opposite now, which was the square root of 7. And our hypotenuse was 4. Cosine is adjacent over hypotenuse, so our adjacent side was 3 over 4. Tangent is opposite over adjacent, so this is the square root of 7 over 3. So now we can start and just take the reciprocal of each of these fractions. So this one is going to be 4 over the square root of 7. But the thing is, we can't have a irrational number in our denominator, so we need to rationalize. So we're going to rationalize by multiplying by the square root of 7 over the square root of 7. So this just equals 4 square root of 7 over 7. So anytime you have a monomial where it's just a single number like this in the denominator, it should start to go really quickly when you are rationalizing. You should be able to see that pattern. So cosine is the reciprocal of secant, so this is going to be 4/3. Cotangent would be 3 over the square root of 7. So again, I need to rationalize, and that is just going to be 3 root 7 over 7. So again, by multiplying by the square root of 7 over the square root of 7, but as you can see, it's just a pattern. It's going to be whatever you multiplied together as a rational number, and then that square root's just going to be in the numerator. So if I'm ever given an angle and I'm asked to find something else, I have that capability. The nice thing about this problem, though, is tangent and cotangent are actually the reciprocals of one another. So that just means that my answer is just going to be the reciprocal of 5, which is 5 over 1, so 1/5. So here is a U-try for you. So you were asked to find the 6 trig functions. So your answers should have been the sine of g is 9 over 41, cosine of g is 40 over 41, tangent of g is 9 over 40, and your reciprocal functions are just the reciprocal, so cosecant is 41 over 9, secant is 41 over 40, and cotangent is 40 over 9.